I'm just going to give you a quick overview of these first 10 questions that you have to do today. So remember, acceleration has to do with velocity, and it's the change in velocity over the change in time. Most of the time, we think that time starts at time 0. So really, it's the final velocity minus the initial velocity over the time. This gives you the average acceleration. We're not going to be working in situations where the acceleration changes. So the average is the instantaneous, and that's all we need. Just the instantaneous or the average velocity. This is what we want. So the first question is just talking about a change in velocity, ranking the magnitude. Remember, magnitude is just the size, so we don't care about it being positive or negative. Again, make sure that you are velocity final minus velocity initial to find that change in velocity. This next question is going from velocity to acceleration graphs. So if we're trying to go from a position versus time graph, remember we find the slope of this line, and that gives us our velocity versus time graph, and then this can be negative. And then when we find the slope of our velocity versus time graph, well, that gives us our acceleration. And so really on this, you're just looking at the slope of these lines and whether you think this student is making the correct decisions on what the slope of these lines creating this acceleration versus time graph. In one of the videos, it talks about how on a velocity versus time graph, if we look at the velocity versus time, one unit, if we were to find the area of this square, it would be the velocity times the time to find this area, which change in position over change in time is just the velocity. So if I multiplied both sides by the time, velocity times time is the displacement. And so finding the area under these curves gives us the displacement. And in this, again, it's the magnitude. So we just care about the number. We don't care about whether it's positive or negative. Remember that if something is below the x-axis, that gives us a negative displacement. And if it's above the x-axis, that gives us a positive displacement. So the magnitude of the displacement for E is actually just going to be 0 meters. And you can decide that this is just the area is 1 meter. You shouldn't have too much trouble with this one. Just remember this is now a velocity versus time graph instead of a position versus time graph. How do we know whether an object is changing directions? Position versus time versus velocity versus time. So this is asking like, well, if it's a position, and this one's asking if it's a velocity. If this is a velocity versus time graph, these velocities down here are negative, and these are positive. So positive things move in the positive direction, and negative things move in the negative direction. This question is sort of, when I think of it, it reminds me of a ball moving, because this acceleration is constant and negative, just like the acceleration due to gravity is constant and negative. And that will help you answer this question. Is the motorcycle always slowing down because his acceleration is negative? Is that true? Again, we're just ranking the magnitude of the acceleration here. Remember, on a velocity versus time graph, the slope is the acceleration. The slope of a velocity versus time is the acceleration. You need to know the same thing for this question. So for this last question, I like to think about a picture, and the bicyclist is moving at high speeds. So here's our bicycle moving, and here's the person on the bicycle, and he's going up this hill. Straight road, and then comes to a hill that slopes gradually upward. She decides to coast up the hill, and the person observing it plots the velocity versus time graph. So does this velocity versus time graph make sense for this bicyclist who's going to be coasting up the hill, meaning they're not going to pedal? What's going to happen to the velocity of this bicycle as it's going up the hill.